let's have a look of several types of this engineering material. Okay, the first one is metal and its alloys as well as application. Metal is normally a solid material which is typically strong and ductile with good electrical and thermal conductivity. For example, iron or ferrum, gold, silver, aluminium and its alloys such as steel. Metal is actually the most widely used material. It is normally strong and ductile, have high thermal and electrical conductivity. Meanwhile, in terms of the optical properties, it is actually opaque and reflective. Meanwhile, for its alloy, it actually formed from one or more metallic elements are combined together with non-metallic elements such as carbon, nitrogen and oxygen. This few application of metal, we can have aluminium can, which is aluminium alloy. It is actually used due to easily form and it's safe to be used with food or drink. The second mostly used engineering material is polymer. It is a substance or material consisting of very large molecules, or we call it macromolecule, composed of many repeating subunits or monomers. Usually polymeric materials are organic compounds which consist of carbon, hydrogen or other non-metallic elements such as oxygen, nitrogen as well as silicon, which intrally molecular bonded by covalent bonding. The most common and familiar polymers are polyethylene, or we can have nylon or even PVC. The polymers or plastics have the widest use because of their low density and high processability. It's actually easy to form complex shapes out of polymers. However, the strength of polymers are weaker compared to even metals or ceramics as well as the composite. So this is actually the main disadvantages to the polymer because it is easily to lose their strength even at low temperature. So general property of polymer is soft ductile, having low strength at low density. It is thermally and electrically insulative. In terms of the optical properties, it can be either translucent, transparent or opaque based on the microstructure, and then it easily decomposed at very low temperature or even moderate temperature of around 100 to 400 degrees C. This is several types of applications utilizing polymers. It's used as a wire or cable. Second is keyboard. Third is actually the packaging of the modern telecommunications equipment. Next, we move to ceramic. Ceramic is inorganic. When polymer is mostly organic, ceramic is inorganic. Non-metallic solid made up of either metal or non-metal compounds such as oxide, carbide, nitride, sulfide. It can be shaped into certain shapes and then hardened by heating to high temperature to retain the shape in order to make a product. It is a strong material, highly resistant to corrosion. However, the issue with ceramics is brittle. It is hard, highly corrosion resistant but brittle. So this is actually the major issues with ceramics. Ceramics are hard and strong not only at room temperature, but it retains its properties at high temperature compared to polymers and some of the metals. Other than hard, ceramics has other general properties such as glassy and elastic. It is able to retain high stress without permanent deformation. So when you have stress over strain, which is deformation, the ceramic can retain the stress without plastic deformation, so we call it as elastic. Meanwhile, ceramic is non-conducting or insulative material. Due to this, ceramic materials are widely used as insulation material because of its good insulative property, which is low electrical conductivity, along with high heat and wear resistance. This is several application of ceramic. This is actually utilizing in the laboratory apparatus as well as filters. This is as pottery, and then we have also nowadays ceramic engine, which is more fuel economy, efficient, weight savings and performance compared to the one from metal. Now we move to composite. Previously, we have metal, polymer as well as ceramic. For composite material, it's a combination. Okay. When you combine one or two more materials, which are metal, ceramic or polymer, to form a new material. This is actually to achieve a combination of properties that is not displayed by any single material. Say for example, when you have polymer, the issues with polymer is it has actually low strength and even having thermal resistance at only low temperature of about 100 to 400 degrees. So how to actually improve this strength as well as the thermal resistance? Okay, by knowing that ceramic material having high strength as well as high thermal resistance, engineers or scientists can add ceramic into polymers to make a composite, to achieve a combination of properties between ceramic plus polymer. Okay? In most composites, one type of material will become the base, or we call it matrix. So as in the case of polymer plus ceramic, since the continuous phases or the highest portion of phase inside the material is polymer, so polymer will be the matrix. Meanwhile, other material, which is ceramic, that we add into polymer is acting as reinforcement. We can classify composite based on its matrix. So we can have either metal matrix composite, short MMC, ceramic matrix composite, CMC, as well as polymer matrix composite, which is PMC. So this is one schematic diagram showing the example of when you have a polymer matrix composite system. So you have fiber here is a continuous fiber, right? This is actually the cross section. This is the cross section. When you have fiber in the matrix phase, the yellow one region is the matrix region and the blue region is the fiber region. However, we can also have naturally occurring composite material such as wood. Okay, it's formed between lignin as the matrix and cellulose as the reinforcement. And then we also have bone, which is a composite. But mostly, composites are synthetic or man-made composites. These are several applications of composites. Okay, we have a golf club, head and shaft, which actually molded to form graphite fiber reinforced epoxy composite. So you have graphite fiber as the reinforcement, meanwhile epoxy, which is one of the thermoset polymer, as the matrix. So combine both materials, we can achieve a stronger, stiffer and lighter material compared to the conventional material. So it allows the golfer to drive the ball farther with greater control. Okay. Another one is utilization of composite material in aerospace. Okay. This is actually one of the composite material that we call prepreg. So the carbon fiber reinforced polymer. So we have carbon fiber, okay, in the polymer matrix. It actually utilized to make sidewall panel of an aircraft. Now we move to material classification based on the functions or applications. So we have this electronic material, some call semiconductors. Why we call it semi? Because in between conductor and insulator. So it shows semi property in between. So we have semiconductor. So for most of the semiconductor material, it has covalent bonding, which actually the electrons are shared between the atoms, and it is very sensitive with contamination. Example of electronic material is silicon, germanium, as well as combination between group 3 and 5 in the periodic table element. We can have gallium arsenide. Okay, so this is actually example of the application of electronic material. We have silicon wafer for computer chips and devices. Nowadays, we have smartphones. Most actually, the smartphone is made of semiconductor material. Next is we have biomaterial. Talking about we have bio from the word biology, and then we have material. So biomaterials are employed in components implanted into the human body for replacement of diseased or damaged body parts. It is actually defined as any substances other than a drug or combination of substances, synthetic or natural in origin, which can be used for any period of time as a whole or as a part of a system which treats, augments or replaces any tissues, organ or function of the body. So these materials supposed to be safe to the body. It must not produce toxic substances. And second, it should be compatible. One, it should not produce toxic substance when utilized in body. And second, it should be compatible with body tissues. It can be either metal, ceramic, polymer, or even composite. So here, example of the biomaterials which actually utilized in hip replacement for people with severe hip damage. Okay, so you see, this is actually the natural one, and this one is when replaced by biomaterial. I believe this one is titanium. Okay, so this is the components of hip implants. So you can see here there are plenty of components that need to be assembled, which actually form from various materials in order to make the hip implant. So it is a very complicated task. Okay, the key problems to overcome is avoiding any debris in cup.